All right, so let's finish up the lesson that we started in class today. We are on question D, and it says, is the number of people waiting in line, which is W of T, to get on the ride increasing or decreasing? Between T equals 2 and T equals 3, justify your answer. Well, remember how to tell if the number of something or the amount of something is increasing or decreasing. We can see if its derivative is positive or negative, okay? So what we want to do is we actually want to find the derivative of W of T. And remember, W of T was this function that we wrote up here. Okay, here's our W of T. Right? And I want to take the derivative of it. So when I take the derivative of 700, that disappears. When you take the derivative of an integral, well, they basically undo each other, okay? And so when you take the derivative of an integral, the integral disappears and you're literally just left with the function, in this case, R of T. And then we have to subtract, and the derivative of 800t is 800. Okay, so if I can if I can figure out what's happening for W prime, if I can figure out if W prime, the derivative of W, is positive or negative between 2 and 3, then I can answer this question, okay? So let's actually find W prime of 2, which is literally finding R of 2 and subtracting 800. And remember, R of T is my graph. So R of 2 would literally be the Y value on the graph when time is 2. So that's 1200. All right, and so that would give us 1200 minus 800 is 400. So W prime of 2 is 400. So at exactly time 2, we know the number of people waiting in line is increasing at a rate of 400 people per hour, okay? Now, if I find W prime of 3, all right, that means I need R of 3 minus 800. All right, well, let's run back up to our picture here. Here's time 3, go up. It touches the graph at 800. All right, and so 800 minus 800 would be 0. Okay, well, that's not positive or negative. But what you can see, let me see, how do I best want to describe this? Okay, so how would I know if all of the numbers between R prime of 2 and R prime of 3 are positive? Okay, well, if I look up at the graph, since I'm going to subtract 800 no matter what time I check, if I go up and I look at the graph of R between, right, so I'm looking at the graph of R between time 2 and time 3, we can see that all of those values, all right, are always going to be greater than or equal to 800, right? All of those Y values are greater than or equal to 800. And so if I subtract 800 from any of those values, I will always be greater than or equal to 0. So if I'm just talking about between time 2 and 3, then I know that I will be positive the entire time. So if I'm positive the entire time, then the number of people waiting in line to get on the ride must be increasing the entire time. So how do I actually explain that that's what I have found? Okay, well, basically we have just said that for any time between 2 and 3, okay, just by looking at the graph, we know R of T, all right, is between 800 and 1200. Those are the Y values. Those are the Y values at time 3 and time 2. Okay, now I put them in numerical order. 800 comes before 1200. All right, so for the time between 2 and 3, we know R of t is between 800 and 1200, which means W prime of t is between 0 and 400, which is what we just proved by finding W prime of 2 and W prime of 3. Well, since W prime of t is positive, right? Being between 0 and 400 means it's positive. Then we know the number of people waiting in line to get on the ride is increasing. And we'll say between t equals 2 and t equals 3. All right, we'll just finish it off. All right, so again, we were able to tell whether the people waiting in line were the number of people waiting in line was increasing or decreasing based on whether the rate of change of W, which means W prime, is positive or negative. Well, what we did was we found W prime by literally taking the derivative of W of t that we wrote in the previous section, all right, and then we plugged in some times just to see what we were working with, all right, but because one of them is 0, it was better if we actually went back and looked at the graph to make sure that we didn't cross over. We would not have gotten a negative before we got to 0. All right, so what we did from the graph was, again, we figured out that R of t, all right, between time 2 and 3 was always going to be between 800 and 1200. And as long as that's the case, all right, I'm saying no matter what I plug in for R of t between 800 and 1200, and not directly on the ends, then I will always get a positive number. In fact, I know that number is between 0 and 400 because I worked out these two ends. All right, and so since W prime of t is positive, right, because it's between 0 and 400, then we know the number of people waiting in line to get on the ride is increasing between those two times. Okay? All right, let's keep moving. All right, E says, what is the value of W prime of 2.5? Well, because we found a formula for W prime in the previous question, it makes it a lot easier for me to figure this one out. All right, because remember we said it was R of t minus 800. And so we're literally going to do the 2.5 into R. All right, so here's 2.5. All right, and I need to figure out, all right, what this is. Now, how do I know that it's exactly at 2.5? Well, I need to think about my slope. Okay, well, at 3, it goes exactly through 800. And at 2, it goes exactly through 1200. And so that would have a slope of negative 400, right? Down 400, right 1. And so then half of that would be 200, down 200, right a half. And so that has to put us on exactly 1,000. Right, so I'm not approximating that. And so that would equal 200. Now, what are the appropriate units? What is the meaning of that? All right, well, I'm going to type this because I can type faster than I can write. All right, so the meaning to that then, and it doesn't matter at which end of your statement that you talk about the 2.5. So I'm going to do it first so I don't forget. So 2.5 hours after the ride opens. All right, so that's where my 2.5 comes in. Remember, W prime, you gotta go back to the previous problem, gave us the number of people waiting in line. So that's what we're talking about, the number of people waiting in line, well, actually gave us the rate of change of the number of people waiting in line. The number of people waiting in line is increasing. How do I know that? Because it's positive. 200 is positive at a rate of 200 people per hour. Okay. Again, you may need to read back the details on the previous page, but W of t represented the number of people waiting in line. So W prime would be the number of people, or the rate of that number of people per hour, okay? And since it's positive, it is increasing. All right, so F says, what is the value of W prime of 3.5? All right, so hopefully you're getting the hang of it. Since we had a basic formula for W prime, we can do the same thing. All right, here we can say W prime of 3.5 is equal to R of 3.5 minus 800. All right, and so then I go to my graph of R, 3.5. All right, since it's on the same, it's on the line, the part of the line that has the same slope, we know that it is decreasing 200 people for every half an hour. All right, so then I know that I fall exactly on the 600. All right, and so when I answer that, I actually get negative 200. So what would that mean about the rate of change of the number of people waiting in line 3.5 hours after the ride opens? Okay, and so I'm going to make a similar statement. I'm going to start by saying 3.5 hours after the ride opens, the number of people waiting in line is, well, since it's negative, we're going to say decreasing at a rate of 200 people per hour. Okay? All right, and then G says, is there a time when W prime of t equals 0? And justify your answer. Okay, well, you'd have to say yes for a couple of reasons. But if W prime, okay, so if W prime is based off of R of t minus 800, and R of t is continuous, which we can see in the picture, then W prime of t would have to also be continuous. Right? So we know based on the intermediate value theorem, because 0 falls between 200 and negative 200, it would in fact have to equal 0. But the fact that it says, is there a time, it's almost like inferring that you need to find that time. Okay? So let's think about it. If I were to ask, is there a place where W prime of t equals 0, then essentially, all right, remember we said W prime of t was equal to R of t minus 800, right? So essentially I'm asking, is there a time when R of t minus 800 equals 0? Okay, that's really what I'm asking here. And that's the same thing as asking, is there a place where R of t equals 800? Okay, and you can go back up to the picture, all right? 800 is right here, and I want to know, is there a place on the graph, is there a time when the graph touches the 800? And it is in fact at time 3 hours. Okay, so we had to do a little bit of interpreting, all right? So we had to remember what W prime of t was equal to, but asking if that is equal to 0 is the same thing as saying R of t minus 800 is equal to 0, which is the same thing as saying R of t is equal to 800. And we can tell by the picture that R of t equals 800 at time t equals 3 hours. So W prime of t equals 0 at time t equals 3 hours. Okay, so sometimes you just have to relate it back to what you're getting. Well, that's the whole point. Anytime you answer these questions, you must relate it back to what you are given. Okay? All right, and then moving on to the last page, H says, when is the number of people waiting in line the largest? Okay, so that's like asking me for an absolute max. Okay, and so we know that the number of people waiting in line will be the largest when the rate of change of the number of people waiting in line is 0 and changes sign from positive to negative. Okay, so let me write that down. Like I said, I can type it faster than I can write it. All right, so we know that the number of people waiting in line is the largest when the rate of change of the number of people waiting in line, right, the derivative of something, right, is equal to 0, is 0 and changes sign specifically from positive to negative. So I'm making that relationship between a relative max, all right, on a function based on its derivative. Okay, well, remember the number of people waiting in line, all right, or excuse me, the rate of change of the number of people waiting in line, all right, is w prime of t. And so I want to know, when is it equal to 0, right? And we already figured that out in the previous part. That happens when time equals 3 hours, okay? And remember, that was because, all right, that's when r of t equals 800. It was all based on the r of t minus 800 equals 0, okay? And so now I just need to prove that that w prime of t is positive before time 3 and negative after, okay? So before t equals 3, all right, how would I prove that w prime is positive? Okay, so let's see. W prime being positive would infer that r of t minus 800 is in fact positive, which would infer that r of t is greater than 800. I'm just using some simple substitution and then solving for r of t. Okay, well, is r of t greater than 800? All right, so here's r of 3, right? Here's time 3. Is r of t in fact greater than 800 before we get to that time? Okay, and since it is between 800 and 1200, r of t is in fact 800. That's what we were hoping for, and so that's what I started writing, but I do have to verify that in the picture in order to leave it there. All right, so now let's see what's happening after time 3. Okay, we're hoping that w prime of t is negative, right? Well, remember, that's the same thing as figuring out if r of t minus 800 is negative, which then would be the same thing as figuring out that r of t is less than 800, and we can see in the graph here that it is. All right, and so since w prime of t is greater than 0 before time t equals 3, and w prime of t is less than 0 after t equals 3, t equals 3 must be a max, meaning the line is the longest at time t equals 3. I guess technically you should, let me go back and add that in. So technically it's an absolute max, and that happens where you have a relative max or at an end point or at an end point, all right? But remember, we know how many people are waiting in line at time 0. All right, at time 0, there are 700 people in line. All right, I'm running out of space, but at time 0, there's 700 people in line. So this is bigger than that. And at the end, when the park closes, there shouldn't be anybody waiting in line. And so it's got to be at that relative max, okay? And yes, technically you should include all of that in your explanation. All right, and then last but not least, what is the earliest time when there is no longer a line? Justify your answer. Okay, so we know it's the longest at time 3, right? So there, like the line has to start to decrease after that, right? So we definitely know that there's not going to be a line sometime after time 3. So I really won't need to worry about what's happening at time 3 or before. All right, but basically what we need to do is we kind of need to guess and check. All right, so how many people are there in line at time 3? Okay, at time t equals 3, all right, how many people are in line? Well, remember, again, in a previous section, we found a formula to figure out how many people are in line. All right, and it was a formula for W. And remember, it said it was 700 plus an integral from the beginning to that specific time, so from 0 to 3, of r of t dt minus 800 t. All right, so if we want to figure out how many people or what is the maximum amount of people in line, then we would plug in 3 here, okay? Now, what I will leave for you to do for practice is to actually work these things out, and then you're going to guess and check. Well, it's not going to be at 3, so then we check hour 4, and then we check hour 5, and we keep going until hopefully we find an answer that is in fact 0. If we don't find an exact answer that's 0, although we will in this case, but you end up getting a negative answer at some point, then at least you can narrow it down to when, like a time interval, like it happens between hour 6 and hour 7 or something like that, and then you can work from there. I will tell you there are multiple ways, okay, to go about this. So you can absolutely do this entire equation again, right? And start over at 0 for each of these. But once you figure out, like I'll tell you that if you work all this out, right, you have to find the area under the graph from 0 to 3. And then, of course, you have to plug in 3 here. Oh, let me do that so you can see it. We really should go ahead and plug in the 3 here because it was 800t. All right, I will tell you get 1,500. Well, if you know that after time 3 there's 1,500 people in line, you can actually just, instead of doing all of this over again, you can start at 1,500 and then just add the number of people from time 3 to 4. But keep in mind that you will only be subtracting 1 hour's worth of people, okay? Because my time interval here is 1 hour. So yes, you can go back and redo this entire equation and make it 0 to 4 and plug in 4 right there for W of 4. Or you can just start at 1,500 and work off of that for just that 1 hour, okay? So you decide what you want to do. And you definitely should work them out, okay? And just to kind of let you know, for W of 4, you should, again, you should go back and practice this. You should get 1,300. For W of 5, you should get 900. So you can tell the line is definitely, the number of people in line is definitely decreasing. All right, when you work out W of 6 and you just decide how you're going to work that out, you should get 500. And then if you keep going, times 7, you do in fact get 0 at time 7. So what does that mean? That means 7 hours after the ride opens, there is no longer a line, okay? So I encourage you to go back and practice and make sure you get these values, and so that you're getting a good idea of how this works. And one more time, the way you find the answer to an integral over a specific interval is to go to the graph of that function and find the area under the graph from that specific time. Over that time interval, you're finding the area of this section, okay? So if I shortcut that second one like I did, and I only go from 3 to 4, then I only need to find the area from 3 to 4 and add it to the one I already have. Okay, so please keep that in mind. That's the whole point of what we're learning right now, is that the integral represents the area under the graph over that interval. And if the area is above the x-axis, that's a positive answer. And if the area is below the x-axis, that's going to be a negative answer. Okay? All right, so I know that took a little longer, but I hope that you do, in fact, understand what's going on. All right.